Okay, we're looking at derivatives of inverse functions. A little bit different type of a lesson. We're going to do an activity in class tomorrow to kind of set this in your mind, because for some reason this stuff really has trouble sticking. Okay, so we want to find the derivatives of the inverse of a function with and without having to find the inverse. Okay, so we'll go back, we'll review inverse, and then we'll kind of try to get going. Oh, sorry y'all. Try this one more time. There we go. Okay. The derivative of the inverse, the theorem says, assume that f of x is differentiable and one-to-one with the inverse g of x equals f to the negative 1 of x. If b belongs to the domain of g of x and f prime of g of b is not equal to 0, then g prime of b exists, and g prime of b equals f prime of g of b, or excuse me, 1 over f prime of g of b. Now let's kind of go back and make sure that we understand exactly what's going on here. Okay, if b is in the domain of g of x, that means if g of x equals some value, and we'll just, g of b equals some value, and we'll call it a, then that means that the ordered pair BA is in the functions, an ordered pair that lies on the graph of G. Well, that means then that if f is the inverse, then f at A would equal B, and so the ordered pair AB lies on the graph of the original function. Okay? It's very important that it's differentiable. That means you can take the derivative at every single point. It's very important that it is one-to-one. Remember that what one-to-one means is something along the lines of a cubic function where it passes both the vertical and the horizontal line tests. Okay? For every x, there's only one y. For every y, there's only one x. If you've got something along the lines of a parabola, then you have to limit your domain in order to make this work. So, here we go. Let's see if we can figure this out. Please write this down. Not always the easiest formula to wrap your mind around. Okay. Important to know that the slopes of inverse functions are reciprocals. So let's just look at, say, y equals 2x plus 1. Okay, that's my original function, so I'm going to call that f of x. If I graph that, 1, 2, 3, 4, down 1, up 1, 2. So I'm at 1, and I need to rise 2 and run 1. So there's an approximate graph. Down 2 and back about 1. So there is approximate graph of that right there. And when I start to find the inverse of that, that means that I would be looking at f inverse, but what I need to do is go back to this one that I wrote originally and trade the x and y. Hopefully we all remember this. And then solve for y. So x minus 1 equals 2y. That means that y is going to equal x over 2 minus 1 half, or 1 half x minus 1 half, whichever way you want to write that. But the thing you need to remember is that this is your inverse function. Okay? Notice that the slopes, just like it was saying up here, the slopes of inverse functions are reciprocals. And you can see that very easily right here with your 2 and your 1 half. So when you graph that inverse, you would go down a half and then rise 1 and run 2. Okay. And so they should cross. I may be a little bit off, but close. Okay, there we are. Probably should have gone back down just a little bit, but that's close. Slopes are inverse, slopes are reciprocals of your inverse functions. That's going to be a big deal as we get into this. All right, I'm supposed to calculate g prime of x using the theorem where g of x is the inverse of the function f of x equals x to the fourth plus 10 on the domain where x is greater than or equal to 0. Okay, if I look at f of x equals x to the fourth plus 10, then go back and think what our formula was on this. Okay, g prime of x equals 1 over f prime of g of x. Okay. That means for this one right here, I need to know what g of x is. So if I go back in and look at this function, then trading my x and y right here, I have x equals y to the fourth plus 10. So then that means that my y value right here is going to end up being the fourth root of x minus 10. Subtract your 10, take the fourth root of both sides. I think we're probably good on that. It said your domain was greater than or equal to 0, so I don't need pluses and minuses and that type of thing on this. So I'm good right there. That is my going to be my f inverse, which in this case we are saying is g of x. Okay, we're calling g the inverse of the function f. So therefore g prime of x would be 1 over f prime of g of x. Well, g of x is my fourth root of x minus 10. Okay, but now I've got to know f prime, don't I? So I go back to my function. Okay. Look at your f of x equals x to the fourth plus 10, and you know that f prime of x equals 4x cubed. So therefore, when I plug this in, I have g prime of x equals 1 over 4, and instead of my x, this was f prime at x, this is f prime at x to the fourth minus 10. Sorry, y'all don't understand what I'm saying when I say this. This is f prime at x, this is f prime at the fourth root of x minus 10. So I've got to plug that in right there. So that's going to be the fourth root of x minus 10 cubed. All right. So, not too bad. We can deal with that. That's not so bad. All right. Try another one. If g is the inverse of f, I'm supposed to find g prime at 8. Now then this was a little bit different. Although we could go through and do all of that, there's not really a need to on this one. So what I have to stop and think of though, okay, and we're back. Sorry about that. That was my husband on the phone, so I had to pause and answer. So if we're doing g prime at 8, then that means I've got to figure out if g was 8, or if g is 8, what does that, what is that? What does that equal? Well, if 8 is in the domain of my inverse function, that means that it was in the range of my original. So I go back to my original function, which was f of x equals x cubed, and that means that x cubed had to equal 8. 8 had to be in the range there. So to find the domain, I need the x value, and we all know that the cubed root of 8 is 2, and so x equals 2. Okay, so g at 8 then would have to equal 2. If the point over here in f of x is 2, 8, then the point in g of x has to be 8, 2. Okay, so remember if we're trying to find g prime at 8, that should be 1 over f prime of g at 8. that's going to be 1 over f prime at g at 8 is 2. Well, I've got to find my f prime. If f of x equals x cubed, then f prime of x equals 3x squared. And I can put that in, 1 over 3, and instead of my x squared, I'll put my 2 in right there. 2 squared is 4 times 3, and I get 112. Okay. So I now know at this point that g prime at 8 equals 112. So that's my slope of the inverse function right there. That means my original had to have been 12. Next problem. All right. Given that g is the inverse of f, I'm supposed to find g prime at 1. Okay, if I need to find g prime at 1, then, oh, excuse me, we'll leave it like that. If I need to find g prime at 1, then that means I need to know the value of g at 1. I'm going to have that. If you'll always go up to the side and write that down, it's going to make these problems easier. If 1 is in the domain of the inverse, it had to have been in the range of the original function. So 2x plus cosine x had to have been 1. That's on 1. Well, great. You know, where is that going to happen? I mean, we're maybe at a loss on that one? Almost, anyway. Because what I know is that if I plug in 0, cosine at 0 is 1, and if I plug in 0 for my 2x, then that's going to be 0. So if I do 2 times 0 plus cosine at 0, then that's going to equal 1. Oh, well then that means that if my x value is 0, my y value is 1. Okay. I know, that's a really nice thing that you might not have thought of off the top of your head. You are welcome to put something like that into the calculator, put 2x plus cosine x into y1, put 1 into y2, and figure out where they intersect. It should be at the point 0, 1, which means that the inverse is 1, 0. Okay, so we have g prime at 1 that we were trying to figure out. That is going to be 1 over f prime of g at 1, well, that's 1 over f prime of, and g at 1 was 0, so we'll put our 0 in there. Well, now I need to find f prime. If f of x was 2x plus cosine x, then f prime of x, going off to the side and writing this down, it's going to be 2, derivative of 2x is 2, derivative of cosine x is minus sine x. So now that when I plug my 0 into that, I have 1 over 2 minus sine at 0, which happens to be 0. So that's 1, sine at 0 happens to be 0. So 1 at 2 minus 0, so that's 1/2. That means that g prime at 1 equals 1/2. Questions or problems? I write them down so you can ask me tomorrow. Hopefully we're doing good. Oh, and my timer's still going and I have no idea how long or why. If you've seen these last few seconds go back and forth and back and forth, sorry, I was trying to get to the right page. We're ready for the homework that I will give you tomorrow in class. Have a great evening. Bye.